This case P again involves an application of the Poisson distribution. We'll write the formula here for the Poisson distribution. We can get the probability that x has any particular value using expression e raised to the minus lambda. Lambda is the parameter of the distribution, and we have our value of lambda in this case of 0.8. Then we'll multiply by lambda raised to the x, and that will be then divided by x factorial. And now that we have this expression, let's take a look what each of these parts of the problem is asking for. In part A, it's asking for the probability of exactly 2 breakdowns. So that's the probability that x is equal to 2. And the next question asks, what is the probability of fewer than 2 breakdowns in that shift? And if you're going to have fewer than 2 breakdowns, that's x less than 2. Well, the only possibilities are 0 and 1 then, so it's a probability of x equals 0 plus the probability of x equals 1. And lastly, part C asks, what is the probability that more than 2 breakdowns occur on the night shift? Well, probability that x is more than 2 can only be obtained from 1 minus the probability of 0 plus probability of 1 plus probability of 2. So we add up those three and subtract the total from 1, and we'll have the answer for part C. So now we need to find each of those probabilities, and we'll do that first with the recursion formula. Well, no, I'll work each of these out individually. So first we have the probability that x is equal to 0 can be obtained as e raised to the minus 0.8, and that's e raised to the minus 0.8, and then when we have 0.8 raised to the 0, that's 1, divided by 0 factorial, that's 1. So we can just write this out then as 0.4493. Next, we have either the recursion formula or a reapplication of this equation now with x equals 1. They're both about the same amount of work. The recursion formula is a little more systematic at this point, so I'll just use that. We can get the probability at x equals 1 from the probability at x equals 0 times lambda, which is 0.8, divided by 1. So that's just 0.44933 times 0.8. The probability at x is equal to 1 then is equal to 0.35946. Next, we need the probability that x is equal to 2, and we can get that from the probability that x is equal to 1, and then multiplying by 0.8 and dividing by 2. If you don't know what I mean by this recursion formula, you'll find it described in the lecture notes. So then the probability that x is equal to 2 can be obtained as 0.14379. So what's the answer to part A? The answer to part A is 0.14379. Now to get the answer for part B. For part B, we need 0.44933. That is the probability that x is equal to 0, plus the probability that x is equal to 1, 0.35946. And when I did that, I got an answer equal to here 0.80879, the sum of those two numbers. And that's the answer for part B. Lastly, we have part C, and in part C we need to apply this formula. So we need to add up three numbers. We add up 0.44933, 0.35946, and 0.14379. We take that sum and we get 1 minus 0. So the sum is 0.95258, and when I subtract 1 minus 0.59258, I get an answer of 0.04742, and that's the answer for part C. So that's the end of case C.